What's up, motherfuckers? Now it's time for some next level shit. What we're gonna do now is we're gonna use power series to find the solution of a differential equation that is equal to 0. And we're given these initial conditions. So y of 0 is equal to 0 and the derivative of y at 0 is equal to 1. So what we're gonna do is assume that y is equal to the summation from n equals 0 to infinity of an times x to the power of n. What does this mean? Yeah, well, if we consider the derivative of y, which we're going to use here, y prime will then be equal to the summation from n equals 1, because you kind of lose 1 with the constant an. When n is power 0, this is 1, so x disappears, so the first term is going to be a constant which will disappear. That's why we do it from n equals 1 to infinity. Of the exponents coming down, an x to the power of n minus 1. Usual derivation, as usual. And then the second derivative will then be equal to, we follow the same pattern, the summation from n equals 2 to infinity of n times n minus 1 an times x to the power of n minus 2. Yes. So now we have y prime and y double prime. So we can write it in terms of this instead of this. So what will we end up with if we do that? So we will get the summation from n equals wait, I think I'm going to skip a step because this might not be pretty. And we're back. So the reason I cut there was to save time, because these videos take up a whole lot of data. So basically what I did was I plugged this into this formula, and the first terms I can understand if you get a little bit lost, but basically how we end up with this one, n equals 0, instead of n equals 2, I chose to rewrite it as n equals n plus 2. So then you end up with this and x to the power of n. The reason I did that is so that we end up with x to the power of n everywhere. And the reason we don't have it here is because here minus x squared will balance out this minus 2. So that's why we start from 2 to infinity here, and then we end up with this. See, this one got cancelled out with this x squared. And then we get the same stuff here. Note here, it's n minus 1 plus 1 because of this x here. I kind of wanted to write it out. And this is 9y, and y is here. Easy money. So now what we want to do is we want to rewrite this as a summation from a common n. Someone wants to reach me on Facebook, but I'm busy. So we want to have a common n. So what we can do is that we can write the terms below 2, because 2 is the highest power, the highest value of n that it starts from. So we write out these two terms when n equals 0 and 1 here, when it is 1 here and 0 and 1 here. And then we can move everything under one summation from n equals 2 to infinity. I'm going to quick scope this. So, quick scoped. Yeah, and from here we know that this has to be equal to 0 for all x's. So basically every single term here, I group these together, have to be 0. So this will be 0 and this will be 0. So we get A2 is equal to negative 9 half A0, and A3 is equal to negative 4/3 A1. Oh, that faggot wants to reach me, but I'm busy. So, basically, these are conditions. And now we know our initial conditions. Here, we have two initial conditions here. And these imply that A0 will be equal to 0 and A1 will be equal to 1 through these two initial conditions, basically. And now, what does this imply? Yeah, this one depends on A0. So A2 will also be equal to 0 because it's just a multiple of 0. And A3 will be equal to negative 4/3. And we weren't quite finished with the expression for everything that has to be 0. Everything within these hard brackets also has to be 0, since it's a factor of x to the power of n, and everything, it has to be 0 for all x's. So basically, if we write that, we end up with an plus 2 is equal to n squared minus 9an over n plus 1 times n plus 2. So now, if you notice that if you're a quickscoper just like I am, too bad they don't have interventions and Barrett 50 cals in the newest Call of Duties, you already see that all the even terms will be 0. Why? Because if we, the an plus 2th term, that's to say the next of the next term, will depend on the term in question. If we start with A0, it will be 0, and an, you can kind of factor it out here. So whatever is here, we don't really give a rat's ass, but the denominator can never be 0 anyways. So we really don't care what's up to the left of this. It will always be 0, because an will be 0 for n equals 0. So an plus 2, a2 will also be 0, and then it's a recursion formula, so all the even terms will be 0. Got that? Yes, good. And if we notice something too, for a3, if we plug in n equals 3, so a5 will be equal to n squared minus 9, and n in this question will be equal to 3, and for n equals 3, an plus 3 equal to 0, because 3 squared minus 9 is 0, yeah, and 0 times anything is 0, so basically everything will cancel. Except a1 equals to 1 and a3 is equal to negative 4/3. So if we recall, at the very beginning, we defined what y is. Y is this expression right here, motherfuckers. I'm such gracious. I'm so fucking gracious when I circle things. I mean, I wrap circles around you. Yeah. Literally. So basically, y equals to the summation of n equals to 0 to infinity of an x to the power of n, and we only a1 and a3 remain. So let's see, so I get everything. Y is equal to a1 times x to the power of 1, so a1 is 1, 1 times x is 1, 1 times x is 1, yeah right, what the fuck have I been smoking? Not crack. So I write it correctly. And then a3, a2 will cancel, so we'll a0, so we'll everything except a1 and a3. So minus, because we have minus here, minus 4/3 x to the power of n, and n is 3. I wrap circles around numbers on square pages. West Side, motherfuckers. Boom!